formations. We kind of went over here to the east, and then we went over here to the west. We are looking at some of these accreted terrains. But then today we met in McCall, and we've driven down south, and now we're all the way down here in Snowbank Mountain. And so we're right along the western Idaho shear zone. And so this is basically all this map was, just to get you all oriented of Riggins versus here.
Eat the mic.
Oh, eat the microphone. Okay, just to get y'all oriented of where we are into relation of where we were yesterday. So then we'll look at this other map, I guess.
Ellen?
Yeah.
Are we, this is a question in our car this morning, are we standing or have we been standing on North America with one side and the accreted terrains on the other?
So if you're looking to the north, North America is going to be to your right-hand side to the east, and then the accreted terrains are going to be on your left-hand side to the west.
And there's a shear zone, so we can't like a fault, right, where you can put a foot on one side and a foot on the other.
No, the shear zone, we had it in miles yesterday.
About 3 miles?
It's about 3 miles across. So if you're in it, you're not really going to be able to stand on one side or the other. You'll just kind of be in the shear zone, which marks this boundary that is the juxtaposition between the accreted terrains in North America. So yeah, we can't get any cool like Lake Itasca kind of standing on either side
If
of
you're
this.
standing in the shear zone, can you say you're in neither?
Either. Both. We're in no man's land.
Do you have an opinion on this, Basil?
No, I don't have an opinion.
Yeah.
All you.
Schrodinger's zone. Yeah, Schrodinger's zone.
So the one thing, that mountain by Cascade is called Little Donner.
Yeah.
Right? And that is all good to Micah, Idaho batholith. So that was unambiguously North America. So you're sort of driving down North America. And then you're coming back. Is that okay?
And the width of the shear zone is shown right on the map there, right?
All right, so this is kind of a regional map of the area. This was done by a student, Nicole Browdy, for some of her master's work and then was published. And so this is showing Snowbank Mountain, the region where we're at up in here, and we're going to be looking at this sort of migmatite domain for a lot of the day. We're a little bit below this, and we're in the Payette River Tonalite right now. After we do some of this talking, we'll go look at it a little bit. But the Payette River Tonalite is a very continuous unit that we see all the way kind of through the western Idaho shear zone. It continues for 200 or 300 kilometers. Yes, 300. It continues for 300 kilometers, and it's very continuous all the way from Orofino down to the south. And it's generally on this eastern side of the western Idaho shear zone. And what we see in here in the real part of this main part of the western Idaho shear zone, remember yesterday we were looking at those really strong fabrics. Those were a lot of solid state fabrics where you're getting this sort of elongation of the quartz grains and stuff. But in this Payette River Tonalite, it's going to be what's called a magmatic fabric. And so you're getting this sort of alignment of the biotites and these sort of mafic minerals, but our quartz and our other minerals aren't necessarily going to be stretched as much. And this Payette River Tonalite, it's been dated, it's about 91 plus or minus a few million years, and that's using uranium lead zircon. And so we're going to be able to go take a little look at that, but I think we'll talk when we're actually looking at the rocks, because it's a little bit easier to see what we're talking about with them. But do you got a question right here?
Yeah, what does Tonalite tell us about its creation? What
Yeah.
form in a certain type of situation?
So tonalite, that's a really awesome question. Tonalite is one of the ways that we're using to classify a lot of these different rocks. So I'm sure a lot of you have heard of granite, but then we're also using these granodiorites, tonalites, and stuff like this. The way that we classify all of these different types of rocks is we use something, it's called a ternary diagram. So it's a big triangle, and it has quartz up here, and then it has potassium feldspar over here, and then it has plagioclase feldspar over here. And then depending on the percentages of those different minerals that you're seeing, that's going to be able to define it. So with our tonalites, we don't have a lot of our potassium feldspar. It's mostly this quartz and plagioclase feldspar composition. And we'll be able to see that when we look over at the rocks here. The other distinct thing...
But the tonalites indicate, because they have less potassium, indicate a non-continental signature. Is that
Yes,
correct?
that's correct.
Okay.
Thank you. That's what I
Thank
was
you.
hoping
Oh,
for.
sorry.
Yeah.
Yeah. And so this Payette River tonalite that we have, it's a very distinctive looking rock. We call it kind of this salt and pepper texture, and you'll see when you look at the rock, does have this nice black and white look to it, and it has these very nice hornblende crystals. So these are these long sort of rectangular crystals in there that we'll be able to see at the rock over there. Do you got another?
Well, we didn't get to the Payette River Tonalite on the Salmon River, did we? It was farther east.
Yes. Yeah, it was to the east of us.
So what's non-continental Tonalite doing that far into the shear zone?
That's actually a great question. At the ends of these shears, it's not, when we say it's non-continental, it's not contaminated by the continental crust. It's basically a pipeline to the mantle, is the idea. Because it's such a direct contact, and it's because the shear zone, we think it's because the shear zone is there that allows these very sort of primitive, that's not quite the right word, but these tonalitic melts to come in. Whereas the Idaho batholith is granites, which are very contaminated by the continental material. So, and it's weird that the tonalite sills show up in every of these vertical shear zones. They show up in Mexico at 90 million years. They show up in British Columbia at 60 million years. We see that this same tonalite sill-like complex over and over again. In Alaska, it goes for 2,000 kilometers. The same tonalite sill, it's called the Great Tonalite Sill. It's compositionally identical to the Payette River tonalite.
So not related to subduction.
Not in any clear way, right? When you get subduction, you tend not to get those kinds of rocks, and you don't get sheets. You get batholiths.
So Tonalite is one area of your triangle of the three minerals.
Yeah, so it's the triangle is broken up into a bunch of different zones. So there's like tonalite, there's granite, granodiorite, monzonite, and it just depends on the different amounts of quartz or potassium feldspar or plagioclase
So
feldspar.
as a scientist, you observe a composition, look at it on your chart. I'm oversimplifying, and then that gets a term of art for what mineral composition, what rock composition you're looking at.
Yep, so like when we have a bunch of these hand samples over here, you pick it up and you make an estimate of, there's 30% of this mineral, and then you're able to plot that on the chart versus the amount of these other minerals in order to be able to classify these different rock compositions.
Now, since it's ocean-based, it's, I assume, similar to basalt then? To some,
no.
somewhat.
No.
This is much more similar to it's a granite, but with
Okay.
different amounts of, there's less potassium feldspar in this.
Okay.
So the amount of silica in it would be about the same as some granites, but the difference is the amount of sodium, sodium and calcium in the plagioclase versus the potassium, which is the continental signature.
So it's lighter in color.
Less pink.
Let's be. Yeah.
Do we have any other questions on that note?
What's the name of that diagram if we wanted to search for it?
The QAFP diagram.
QAST
FP. F.
SP.
F is in
F as in Fred.
Free person.
P as in person.
QAFP.
Yeah.
Got it. Thank you.
Probably if you looked up
next time you
granitic
bring one of
rock
those.
classification, you would find granitic rock.
So the shear zone, as we track south from here, apparently dives under the Treasure Valley and reappears in the Oahe Mountains. Do we have a tonalite there?
Yeah, so there's a tonalite kind of going all the way down through there, down to the Oahes. And so, yeah, we can track this shear zone. And this is actually a pretty good poster to talk about. So at this migmatite complex, we're actually seeing kind of a long strike variation in the fabrics. So when you're north of this migmatite complex, they're all oriented, all of the foliations are oriented about north, about 000. But once you move south of here, there's a little bit of this variation, and they're oriented a little bit more 020. And so that's what these are sort of showing is, these are a way we kind of present our different orientation measurements. And so this right here is representing an average plane of these foliations. And so up here, this is just showing that this is striking about north. So those foliations were striking about north, but then down here, they're about 020.
Meaning 20 degrees.
20 degrees away from north.
This whole quiz and shear zone, this is what the strontium 90 line is.
Yes, this goes right along the strontium 706 isopleth. Yeah. Yep. Awesome. So we're gonna go look at the rocks. I do want to give a quick tangent about so I was the one that was doing some of the scouting for these roads, and I had the locations, and I pulled up to this outcrop, and I said, this isn't a super great outcrop to bring 80 people to. If you look at it, it's like, you know, it's not quite as impressive as all the field trip stops we were looking at on the other days. But then I decided this is a great reason to come here, because this is a good example of what we actually work with in the real life. If I came across this outcrop while I was doing some work, I would be very excited, because these rocks are definitely in place. You can see them. They're right on the road, so you don't have to like hike up to them. So I think this is just a good example to see. Like, this is a lot of what you're dealing with when you're making these observations that go onto these larger maps and then go into these larger models. But, yeah.
Okay, we're going a little off program here for just a second. So what we're going to do is Ellen will go stand by this pile of rocks. So Ellen and I spent some time bashing rocks, so everybody can pick up a hand sample and look at this tonalite. So we'll do that. And then Annette had an announcement, so that's really why I grabbed the microphone.
I don't know.
You just press this in and talk really very close to it.
All right. Hello.
Eat the mic.
Eat the mic. How's that? Okay, a lot of you might know Yuki on Facebook.
Yeah.
Any rate, I've got a book here for people to sign and maybe tell her, because she couldn't be here today and she really wanted to be. So I thought maybe people might say hi to her or something like that. Any rate, I'll have that here today and this evening, and if you guys would like to, that would be great if you could jot her a little note. Thank you.
That's
And
an
I have
awesome
one quick
idea, Annette.
announcement.
Okay.
No, you can hear me. Trust me. I taught 30 years. Everybody can hear me. I picked up the water from last night that was left at our meeting spot and put it in a cooler, added a bunch of water to it. It's sitting in the back of this Honda Ridgeline with the camper. You can't miss it. If you need some, there it is.
Thank you.
Right, okay, and we're gonna leave the book to sign on the hood of this car. I hope whoever's car that is doesn't mind us doing that.
Same car.
Great, and we'll just go back and look at some tonalite up close and personal.